Good morning, I am Devasena. In this lecture, we are going to discuss about Z parameters or open circuit impedance parameters. This topic is present in the subject circuit analysis under the unit two-port networks. Z parameters are also called impedance parameters. These are obtained by expressing voltages at two ports in terms of currents at two ports. Thus, currents I1 and I2 are independent variables, while the voltages V1 and V2 are dependent variables, because impedance is the ratio of V by I. The term that is present in the numerator is considered to be a dependent variable, while the term that is present in the denominator is considered to be the independent variable. Here in the Z parameter, that is the impedance is equal to V by I. The voltage is the dependent variable, while the current is considered to be the independent variable. Thus we have V1 is equal to the function of I1 and I2, and V2 is the function of I1 and I2. In equation form, the above relation can be written as V1 is equal to Z11 I1 plus Z12 I2. Consider this as equation 1. While V2 is equal to Z21 I1 plus Z22 I2. Consider this as equation 2. In matrix form, the above two relations can be written as matrix of V1 V2 is equal to matrix of Z11 Z12 Z21 Z22 into matrix of I1 I2, or matrix of V is equal to matrix of Z into matrix of I. The individual Z parameters can be obtained by assigning value of the independent variables. Let I2 is equal to 0, that is port 2 is open circuited. Therefore, from equation 1 we have V1 is equal to Z11 I1, because the value of Z12 I2 is considered to be 0. Therefore, Z11 is equal to V1 by I1. Here we have considered I2 as 0. The unit of Z11 is ohms. That is, the parameter Z11 is called open circuit driving point input impedance, because Z11 is the ratio of input voltage to the input current. That is, Z11 is equal to V1 by I1. From equation 2, we have V2 is equal to Z21 I1, because the term Z22 I2 is considered to be 0. Therefore, Z21 is equal to V2 by I1. Here, I2 is equal to 0. The unit of Z21 is ohms. The parameter Z21 is called open circuit forward transfer impedance, because Z21 is the ratio of output voltage to the input current. That is why it is called as forward transfer impedance. It's the ratio of output voltage to the input current. Let I1 is equal to 0. That is, port 1 is considered to be open circuited. From equation 1, we have V1 is equal to Z12 I2. Here we have considered that I1 value is 0. Therefore, Z11 I1 term will not be available. Therefore, the value of Z12 is equal to V1 by I2 at I1 is equal to 0. The unit of Z12 is ohms. The parameter Z12 is called open circuit reverse transfer impedance, because it's the ratio of input voltage to the output current, that is Z12 is equal to V1 by I2. From equation 2 we have V2 is equal to Z22 I2 because the term Z21 I1 is equal to 0 as the value of I1 is considered to be 0. Therefore, Z22 is equal to V2 by I2 at I1 is equal to 0. The unit of Z22 is equal to ohms. The parameter Z22 is called open circuit driving point output impedance because Z22 is the ratio of output voltage to the output current, that is V2 by I2. Therefore, it is called as driving point output impedance. Moreover, these parameters are defined only when the current in one of the ports is 0. That is, either I1 is considered to be 0 or I2 is considered to be 0. This corresponds to the condition that one of the port is open circuited. Hence, Z parameters are named as open circuit impedance parameters because here the current, that is I1 and I2, is considered to be 0, that is open circuited. The equivalent circuit of a two-port network in terms of open circuit impedance parameters satisfying equations 1 and 2 is shown in figure. This is the equation 1. Equation 1 comprises of V1 is equal to Z11 I1 plus Z12 I2. This is the equation 2. Equation 2 comprises of V2 is equal to Z21 I1 plus Z22 I2. This is the representation of an equivalent network of a two-port network in terms of Z parameters.